4. The laws of nature are universal. One of the most fundamental presuppositions of science is that the laws of nature are universal. It would have been impossible for us to make scientific projections either into the past or the future if the laws of nature, which determine the processes in the universe, were not universal in time. Both the sciences of geology and cosmology, which study the past, depend on the supposition that the laws of nature are the same today as they were in the past. On the other hand, the fact that the laws of nature are universal in space grounds scientific disciplines like astrophysics, which study objects that vastly exceed our physical reach. The universality of the laws of nature is also necessary for our daily lives. Without them, we could not judge the outcomes of our daily actions. If the law of biology that requires us to drink water in order to live kept changing, or if the law of gravity which causes us to fall down when we jump from an elevated place kept changing, it would have been impossible to know the results of our actions, and so impossible to live a normal life. Every scientist, therefore, assumes that the laws of nature are universal. There are 4 different universalities in regard to the universality of natural laws. 1. Laws do not make reference to spatio-temporal location. 2. Laws have unlimited range in space and time. 3. Laws do not contain space and time coordinates explicitly. 4. Laws are invariant under space-time transformations. The universality of laws is closely related to the problem of induction, a crucial subject in the philosophy of science. Induction is the process of finding a general principle, one that in principle applies to an infinite number of things at an infinite number of times from a finite number of observations. For example, after observing repeatedly that particles with the same charge repel each other, if we conclude that all particles with the same charges repel each other, then we would be engaging in induction. How rational is this process of induction? In other words, is the knowledge gained through induction trustworthy? According to the famous philosopher David Hume, the answer to this question is negative. For him, induction has no rational justification. The problem with induction is its quest for rational justification of induction. The problem of induction is closely related to the universality of the laws. Hume was aware of this. For him, if it was assumed that the laws of nature were universal, the mentioned problem with induction would vanish, because as the result of the observations conducted many times in the past, prediction can be made about the future with the assumption that the universe has fixed laws, and these deductions can be trusted. But Hume claimed that this assumption, since it is related to induction itself, cannot solve the problem. According to Hume, the universality of laws can only be grounded through induction, and induction can only be grounded through the universality of laws. Because of the logical difficulties with induction, some philosophers argue in favor of falsification. According to this proposition, proposed by Karl Popper, since no universal scientific law can be established or verified or confirmed on the basis of a finite set of observations, Popper claimed that a statement is scientific only if it can be falsified with empirical and observational data. For example, the assertion that like-charged particles repel each other is scientific because, at least in principle, one could observe like-charged particles that do not repel each other. Therefore, the negation of that assertion can be proven experimentally, but because of the problem of induction, it cannot be claimed true. Even though falsification has lost its former popularity in philosophy of science, it is still respected by many scientists. Some wrongly assume that only induction is based on the universality of the laws, whereas in reality, falsification is also closely related to the same universality. If the universality of the laws is not accepted as a presupposition, then we cannot know whether a proposition that has passed the test would not be falsified by the same test in the future, and a proposition that had been falsified would pass the same test in the future. Let us take the proposition, like charges repel each other, as an example. This proposition could be falsified easily by an experiment conducted with any two particles of the same charge. For example, if we put two electrons together, we could see that they attracted each other. According to Popper, this observation would be sufficient to falsify the proposition here, and hence, like charges repel each other is a proper scientific statement. Well, then, how do we know that two electrons will not suddenly start attracting each other tomorrow? Without assuming that the laws governing the charges will stay the same, it is not possible to make this inference. So, falsification is also connected to the presupposition that the laws are universal, that they do not change in time, and they do not emerge and disappear suddenly. If we abandon this presupposition, then falsification will become unreliable. In the naturalist paradigm, there is no reason to expect universal laws. According to physicist Paul Davies, to be a scientist, you had to have faith that the universe is governed by dependable, immutable, absolute, universal mathematical laws of an unspecified origin. You've got to believe that these laws won't fail, that we won't wake up tomorrow to find heat flowing from cold to hot, or the speed of light changing by the hour. Over the years, I have often asked my physicist colleagues why the laws of physics are what they are. The favorite reply is, there is no reason they are what they are. They just are. On the other hand, the theist Isaac Newton, the towering figure of the scientific revolution, correlated the universality of the laws of nature and theism. If there be an universal life, and all space be the sensorium of a thinking being, God, who by immediate presence perceives all things in it, then the laws of motion arising from life or will may be of universal extent. In the previous chapter, we have mentioned two possible approaches of a naturalist towards the laws of nature. If the laws of nature are records of regularities in nature, as the regularity approach claims, and if these regularities are the result of cosmic coincidences, then there would be no reason to expect that these regularities would continue in the future, or that they would exist in the parts of the universe we cannot observe. Let's give an example to comprehend this better. Imagine we are visiting a city in a new country for the very first time. Suppose that in our first few days, all the taxis we see are blue. From our observations, what can we infer about the colors of other taxis in that city? Not much. We should assume that all of the taxis in that country are blue only if we have an explicit reason for thinking all of the city's taxis are blue. Lacking such an explanation, we should think it sheer coincidence that we have seen only blue taxis so far. We should rationally refrain from generalizing from our very finite experience to the claim that all the city's taxis are blue. Even if we were to continue to observe only blue taxis, that would also likely be a coincidence. We'd have no reason to think it's not. Without a well-grounded assumption of the universality of the laws of nature, the regularities we observe in nature could be, for all we know, mere coincidences. Our very finite experiences of regularities would be like our very finite experiences of blue taxis. Interesting coincidences with no good reason to think that they apply beyond this particular time and place. Without a well-grounded assumption of the universality of the laws of nature, we have no reason to think these regularities are the same in the future and the past, or that they are valid throughout the entire universe. According to the regularity approach of the laws of nature, the apparent universality of the laws of nature is nothing but a surprising coincidence. It provides no reasonable expectation of universality. The universality of the laws of nature is also surprising given the second approach of the naturalist, the claim that laws of nature are necessary relations between universals. The propositions, there will be a relation between universal A and universal B until eternity, and there will be a relation between universal A and universal B until time t, explain our past observations equally well. But if the second proposition is true, the law described by these universals is not universal. This law will be invalid after time t in the future. From the naturalist point of view, there is no reason to prefer the first proposition over the second. Worse, since the time t can take infinitely many different values, and since a naturalist cannot present any reason to prefer the first proposition over any subset of the second one, for example, t equals 10 millennia later, the second proposition is infinitely more probable compared to the first one. Therefore, from such a naturalist point of view, there is no rational way to expect for the laws of nature to be universal. On the contrary, one might even claim that the expectation is higher for the laws of nature to be invalid someday in the future. As a result, a naturalist has no rational reason to expect the laws of nature to be universal, regardless of whether he or she sees them as the description of regularities or as necessary relations between universals. From a theistic point of view, however, the universe has been created and is being sustained by the Supreme Creator. Since God is immutable, a change in His nature is not in question. Therefore, it is expected that the laws designed and protected by God, whose nature does not change, will also be unchanging in time and space. Another reason the theist might expect the laws of nature to be unchanging is the belief in the oneness of God, and in that He is the Lord of all beings, both emphasized in the Quran. The belief that God is the Lord of all beings offers a rational base for the laws to remain the same at all times and locations. According to polytheism, different gods control different phenomena and different regions. Though each region might have its own laws, there is no reason to think these laws are universal. In polytheism, the laws of nature would likely differ from region to region and from phenomenon to phenomenon. Moreover, in polytheism, since gods are often at war with each other, gods who are dominant in a certain region or over a certain phenomenon may lose their power. The victorious gods may then change the laws in those regions or for those phenomena. Therefore, from a polytheist point of view, we should expect laws to be both location and time dependent, anything but universal. The following verse of the Quran points out to the chaos that would emerge if there were gods apart from the one God. Had there been gods apart from God, both the heavens and the earth would have been despoiled. According to monotheism, however, one entity created the universe and determined and sustains its laws. The idea that there is one absolute master of the universe supports the belief that the laws of nature are universal. According to Nobel laureate biochemist Mervyn Calvin, monotheism's commitment to the unity of the universe grounds the universality of laws assumed in the foundations of modern science. He writes, "The fundamental conviction that the universe is ordered is the first and strongest tenet. As I try to discern the origin of that conviction, I seem to find it in a basic notion discovered 2,000 or 3,000 years ago, and enunciated first in the Western world by the ancient Hebrews, namely, that the universe is governed by a single God, and is not the product of the whims of many gods, each governing his own province according to his own laws. This monotheistic view seems to be the historical foundation of modern science." Within the theistic ontology of the Quran, another reason for the expectation for the laws of nature to be universal is, again, the world as a trial place. For the trial to be just and meaningful, people need to be able to accurately predict the outcomes of their actions. This can happen only if the laws of nature are universal. For example, if we give water to an old man in order to help him, and if all of a sudden the laws of biochemistry change and the water becomes poisonous, then this action would end up killing the old man. Such trials would lose their meaning in a universe in which people cannot predict the outcomes of their actions. Therefore, our being in a world of trials supports the presupposition that the laws of nature are universal. The paramount message of the Quran is the oneness of God. This message and the teaching of the Quran about the world of trial support the presupposition that the laws of nature are universal. Of course, many scientists share this presupposition without even sharing an ontology and worldview which support it. But the ontology and mindset of the Quran afford a rational basis for believing that the laws of nature are universal. Thus, the Quran supports scientific activity.